Okay, so today we're doing section 3.6. It's called arithmetic sequences as linear functions. Sounds kind of difficult, doesn't it? A lot of words, a lot of big words, a lot of syllables. Arithmetic. See, yeah, okay. You guys, it's really just a pattern of numbers. So I'm gonna zoom in here a little bit, and we're going to look at this arithmetic sequence concept over here. Arithmetic sequence concept. Okay. An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate called the common difference. Okay. Basically, this is what it says. We have a pattern of numbers. We have a pattern of numbers. And to get from one term to the next term, we have to add or subtract the same value over and over and over again. So you see their example on that first one right here. They start with 3, then add 2, and then add 2, and then add 2, and then add 2, and then add 2. Okay, so that's your pattern. You keep adding 2 over and over and over again. That's an arithmetic sequence, because you're adding the same value over and over and over again. And that's called the D, common difference. Okay. Over here, we have another one. It starts at 33, and then it goes down to 29, and then down to 25, and then down to 21, and then down to 17. So it's losing 4, it's subtracting 4 over and over and over again. That's your common difference. Both of these are arithmetic sequences, okay? That's a different than a different pattern. Maybe another pattern has you multiplying to get to the next term. That is not an arithmetic sequence, okay? So here's what we have for our vocabulary. A sequence is just a pattern, right? The terms of the sequence, that's these guys, 1, 2, 3, 4, 5. So the first term is 3, the second term is 5, the third term is 7, the fourth term is 9. Those are the number of terms, the term number, okay? Arithmetic sequence means we have a pattern that you're adding over and over and over again. Now I can say it's adding or subtracting, but subtracting is really just adding a negative over and over again, right? So it means the same thing. And then the common difference, that's the number that that's being added over and over and over again. So example 1, we have to determine if these are arithmetic sequences. So let's start here. Our goal is to find out if we add the same value over and over and over again. Sometimes it's easy to tell, right? These are negatives, and negatives aren't so easy all the time. So what I like to do is I like to go backwards. So this is term 1, this is term 2, this is term 3, this is term 4. I'm going to go backwards. We're going to take term 4 minus 3. What is 2 minus 0? Here, let's move this. So we're going to go like this. How do I get, what's 2 minus 0?
2.
2. Now let's go backwards here. What's 0 minus negative 2?
2.
2. What's negative 2 minus negative 4? 'Same change opposite. 2. So you guys, is that an arithmetic sequence?
Yes.
Yes. Yes, it is. And the reason we can tell is because when we subtracted over and over and over again from the next term minus the previous term, we got that same same value, okay? So letter B, that's a doozy. We got fractions. Ew. That's why we use calculators, right? So what we're going to do is we're going to take 13/16 and we're going to subtract 3/4 from it. Ew. 3/4 is really 12/16, isn't it? So 13/16 minus 12/16 is 1/16, correct? Or we can just use a calculator. I don't have a calculator handy, so I got to do it by hand. Now I'm going to take 3/4 and I'm going to subtract 5/8. Oh boy, I need a common denominator, don't I? Multiply by 2 and I get 6/8 minus 5/8. What's 6/8 minus 5/8?
1/8.
1/8. Whoa, do I have to do any more?
No.
No, 1/16 and 1/8 are not the same. So this is a no-go. This is not an arithmetic sequence because we do not have the same exact value that makes one jump from one term jump to the next term. All right, is everybody good so far? Speak up if you have any questions because I can't see everybody's heads nodding or not because there's too many of you to be on one page. All right, I got to turn this off. Stop. Okay. So let's try the next one. 25. Notice I'm always going backwards here, right? 25 minus 9 is
16.
all right, Garrett, this one's yours. 9 minus 4.
6.
Almost.
5.
5. Oh, hey, what does this tell us, Grady? Is this arithmetic or not?
Yes.
In order to be an arithmetic sequence, go back up here. See all these jumps? Have to be the same number over and over and over again. Do we have the same jump?
No.
Nope. So this is a no. All right, let's try this last one. I've got a lot of stuff here. Let's see. I'm going to move it. Okay, so we're going to do this. -14 minus -18. All right, this is for Mason. What is -14 minus -18?
32.
Do a same change opposite though. So same change opposite. Now what do you got?
2 or 4.
4, right. So this is 4. All right, the next one, we're gonna do -18 minus -22. Sean, what do we get with this? -18 minus -22. Do a same change opposite. So same change opposite. So now we have -18 plus 22. Sean, you heard me say your name, right?
Yes, I did.
Okay, so process this. -18 plus 22. What do you get?
+4.
Absolutely. So that's 4. So it looks good so far, right? But we got to complete it. We got to keep going. Make sure everyone is the same. So -22 minus -26. Braden, what do we get?
4.
4. So you tell me, is that arithmetic or not? Grady is nodding his head yes. I can't see Grady. He is correct. Okay. So you guys, what do we know about an arithmetic sequence? Let's see.
That they're constant.
Okay. So you have a constant number that you do what to each of those terms? What is the operation that you do with that constant number?
Add it.
Add it. Add or subtract, right? Because if it's a negative, it would be subtraction. Okay, so arithmetic sequence, you're adding over and over and over again. Interestingly enough, here, let me do this. This is all bonus. We are taking these arithmetic sequences later on and making it into a linear function. I'm going to show you how we do that. Remember how letter A was, the answer to that was yes, it was an arithmetic sequence. I could put this in a t-table. So this would be my term number, which is actually going to be called A1. And this is going to be the term itself. Wait, no, hold on. I lied. This is, well, let's just do an XY there. So -4 was term 1. No, I did that again, wrong. Term 1 is -4. Term 2 is -2. Term 3 is 0. Term 4 is 2. Could I find the next 3 terms in this sequence?
Yeah.
How would I do that?
You'd add 2 to the next 3 numbers.
Right, so I'd add 2, so I'd get 4. Then I would add 2, and I would get 6. And then I would add 2, and I would get 8. And that's how I can get the next 3 terms in that sequence. How many of you think so far this is not too bad? All right. The concepts are not bad. It's just when we get all these new notations, that's where it gets a little tricky. Okay, so let's go back to something that looks more like something you would see in elementary school. You know, when math was easy back in the good old days? We have example 2. It says find the next 3 terms of the arithmetic sequence. Okay, well, it's 15 and then 9 and then 3 and then -3. We know it's arithmetic. So we already know that there's some number that's being added over and over and over again to get to the next number, right? So how do I find out what that number is that's being added over and over again?
You know what? I'm gonna let someone else answer.
Let's see. Caitlin, do you know? How would I find out what the number is that I'm adding over and over again?
You would look at the sequence and take 15 minus 9.
Very close. We're actually going to go backwards. So we're going to do 9 minus 15. So what's 9 minus 15?
-6.
Right. So that's the number that's being added each time. So we added -6, Then we added -6, or you could say you subtracted 6. We subtracted 6. So to get to the next 3 terms, I'm going to take -3 minus 6. That's going to be the first of the next 3. So Addison, what do we get with that? What's -3 minus 6?
-9.
Right. So there's my first one. So I'm going to pop that right on the end here. And then I'm going to take -9 minus 6, because that's my common difference. That's the name of it. Common difference, otherwise known as D. Later on, we'll describe it as D. Okay, so -9 minus 6. Jacob, what do we get?
-15.
Correct. So that's the next one. I only have one more to go. So -15 minus 6. This is where those calculators come in handy. Hunter, what's -15 minus 6?
-21.
Right. So that's my answer for the next 3 terms of that sequence. Okay. Finding that common difference, that's the key to the whole thing. That makes life so much easier. Okay, so we got another one to try out. We're going to do the exact same thing, except for this time we have decimals. It's hard if we're trying to just mentally describe how to get from here to here. But if you remember, all you have to do is go backwards and subtract, then it's not as hard. So 11 minus 9.5 is going to give us our common difference. What's 11 minus 9.5, Vincent?
$1.5.
Absolutely. So 11 minus 9.5 is 1.5. Now that is not a term. That's our common difference. So you know what? I'm just going to call it D. Okay, so 1.5 is D. That's what I add each time. So now we go to our last number, 14. To get to the next number, what do I have to do, Anna? How do we get from 14 to the next term?
You add 1.5.
Absolutely. So what do I get?
You'd get 15.5.
Correct, 15.5. Okay, Nate, how do I get the next term in the sequence? What should I do to get the next term? Nate, are you there? Nate, are you in the classroom? I know you're in, but are you actually here? Okay, do you guys remember how I asked you to I said that, hey, if you didn't respond to my questions, then I was going to mark you absent. Do you remember that? Okay, so
I no, I don't remember that. What?
I think that might have been because you
No,
were
what? Huh?
not here.
What?
Okay, Nate, what do I do to get the next term in the sequence?
Add 1.
Almost. What's our common difference?
I don't know.
Look at the screen. Can you see the screen?
Yes.
What is D equal to?
1.5.
Right, so what should we actually add?
I don't know.
We're gonna add
1.5.
1.5 to what number? What's our
I
last
don't
term?
know.
What's the last term that we have?
Is it 21?
We're actually on example 3 right now, so we're down here.
Oh,
See the last term that Anna found,
14.
actually Anna found 15.5.
How did she do that? It's crazy.
Yeah, you must have missed out on that. I wonder what you were doing.
No, I was watching the whole thing.
Well, then you saw her get take 14 and add 1.5, and she got 15.5, which is why it's sitting right here. So now you're going to take 15.5 and do what with it?
Do I subtract?
Nope. We're going
I
to
should.
add 1.5.
But you already did.
We're going to add 1.5 to 15.5 to get the next term.
Okay.
And what do you get?
17.
Correct. All right. That wasn't painful at all.
That was easy.
Yeah, you know what? It's actually kind of easy when you pay attention. Okay, who's next? Sophie, go ahead, find the next term for us. What do we do?
Add 1.5.
To what?
17.
Correct. So 17 plus 1.5 gives us
18.5.
perfect. Okay, now we have our 3 terms, we're done. It's really not that painful to go ahead and first of all, check to see if it's an arithmetic sequence, which is what we did on example 1, and then find the next 3 terms in the arithmetic sequence like we did in examples 2 and 3. Okay, now it gets a little complicated because we're going to take those sequences and we're going to turn them into a linear equation. Okay, so if you look here, and this is something that you really want.
Why can't we just have it easy? Like, we have all this, it's all set up nice and easy. Why do we have to make it more difficult?
All right, well, here's the thing. You learned about sequences back in elementary school, right? You learned how to find the next numbers in a pattern in elementary school. So if all I did was do examples 1, 2, and 3 with you and said, okay, we're good, then you wouldn't get any smarter than you were in elementary school. And you know what? I got to get you smarter than that, right? So that's where we take what we knew, take what we did before, and we're just going to kick it up a notch, okay? It's all going to be good. Trust me. This right here is something you want to have in your notes because this is the key to the whole arithmetic sequence as a linear equation thing. Now, there's a lot of letters in there, aren't there? D is something we already know what that is, right? That's what you add over and over and over and over again. A1 is your first term in the sequence. And N is the term number. Okay, so N is going to be like our X. So think of N, here, let's try this. N is kind of like X, and AN is kind of like Y. And hopefully that helps you see that it's like a linear equation, okay? So N and AN are going to stay variables. We're not going to plug numbers in for them. We have example 4A. It says write an equation for the nth term, so that would be like x, of the arithmetic sequence -12, -8, -4, 0, etc. So here's what we need to do from this pattern. We need to identify the common difference. Remember, that's the number that we keep adding over and over and over again. And we need to identify our first term. Well, the first term is easy, right? What's the first term in this sequence?
9.
I'm sorry, what?
-12.
-12. So that's easy. We found our first term because it's the first number in our pattern. Now we have to find the common difference. That's something we did in example 1. So let's go backwards. 0 minus -4. 0 minus -4. Do same, change opposite. Do. And D is 4. Did everybody see where the A1 came from? Did everybody see where the D came from? Okay, now what we're gonna do is we're gonna take this base equation and we're gonna plug in our D goes here. This stays the same because remember n is like x, so that stays the same. Plug in our A1. AN stays the same. And that's my equation. Huh? How's that? Not too bad? All right, so letter B says find the 9th term of the sequence. Do you know what that is? That stands for n. So we want n equals 9. So we're going to plug 9 in for n. And that's going to tell us what the 9th term of the sequence is. So I'm going to call that A9. That's -12 plus parentheses 9 minus 1 times 4. Now it's just a simple a simple PEMDAS. So let's do this first. We have 9 minus 1, which is 8. 8 times 4 is what is 8 times 4? Jaden? Jaden? Jaden?
2.
8 times 4, not divided.
Yeah, 32.
Oh, I'm sorry. I thought you said 2. It kind of cut out. All that glitchy tech stuff. Okay, now -12 plus 32, Lauren. Yep. Okay, so the 9th term is 20. Okay, now we have to graph it. So you know what? I am going to go back. I'm going to get rid of this because I can't just erase it. So let's do this. We have to graph the first 5 terms of the sequence. So you guys, what I'm going to do is I'm going to make this a table of values. Here's my n, here's my an. First term is -12. Second term is -8. Third term is -4. Fourth term is 0. What's my 5th term going to be?
4.
4. So to graph this, I have 1, negative 12 way down here. 2, 8. 3, negative 4. 4, 0. And then 5, 4. You guys, it looks like a linear line, but it's not. Do you know why it's not? Our terms are negative 12, negative 8, negative 4, 0. If I connect the dots like this, then that means I'm getting all the numbers in between those points as well, and it doesn't. So this, when you graph these, it's just a series of dots, not a line. Okay, does that make sense?
I'm confused with the graphing part.
We just take, okay, so you go back up to your sequence, right? This is term 1, this is term 2, this is term 3, this is term 4. The term numbers is your X. The term itself is your Y's. So then you just graph that ordered pair, graph that ordered pair, graph that ordered pair. Okay?
What does AN mean?
All right, so AN is like your Y, N is like your X. N means the term number, and AN means the value at that term number. So here we have term number 3, the value of it is negative 4. So 3 would be your N, your AN would be negative 4. Okay, you guys, I think the best thing to do is to get you started with it. We're not going to do example 5. You're just going to go ahead and do your homework. Page 194, 1 through 23.
Are we skipping example 4D?
Yep, we're skipping that one too.
Oh, okay.
So you're going to just go ahead and get started on page 194, 1 through 23. Hopefully, once you actually get going on this, it's going to be clear. If not, I do have after school today from 3 to 3:30 or office hours on Zoom, or you can ask in class before we grade on Monday, okay?